Okay, so continuing with section 7.2, let's consider well, we know that the first, actually, let me move this down a bit. The law of cosine states that a squared is equal to b squared plus c squared minus 2 times b times c times cosine of angle A. So let's isolate cosine of angle A. So what I'm going to do, let's subtract b squared from both sides. So we get a squared minus b squared is equal to c squared minus 2bc times cosine of angle A. Now let's subtract c squared from both sides. So we get a squared minus b squared minus c squared is equal to negative 2bc times cosine of A. And last but not least, let's go ahead and divide by negative 2bc. Negative 2bc. Negative 2bc. Okay, so on the right, the negative 2's reduce, the b's reduce, and the c's reduce. So what I'm left with then is that cosine of A will be equal to a quotient, but I'm going to swap the order. I'm going to make it a positive b squared, a positive c squared, and a negative a squared, all divided by a positive 2bc. So I just put the negative into the numerator. Okay, so let's note. So the law of cosines gives us the law of cosines gives us number 1, that cosine of angle A is equal to b squared plus c squared minus a squared over 2bc, or cosine of angle B is equal to a squared plus c squared minus b squared all over 2ac, or cosine of angle C is equal to a squared plus b squared minus c squared all over 2ab. So once again, you can see the pattern here. What do we have? We have that c minus c squared. We have b minus b squared. And we have a minus a squared in these formulas. So that's one mnemonic device. Okay, so note also that each of these implies respectively that A will be inverse cosine of these quotients. Copy and paste. So if I want to solve for the angle, I just take the inverse trig of both sides. And in the second case, we have that B will be equal to cosine inverse of this quotient. I didn't like that. And last but not least, for angle C, we just take inverse cosine of its quotient. go ahead and do a couple examples. So for example, so solve the following. Solve the following triangle ABC. ABC, C, given that the measure of length the length of side A is 3, the length of side B is 4, and the length of side C is 5. So this, of course, is side, side, side. I'm given 3 sides, so I know I can't use the law of sines, unfortunately. Okay, so in this case, I need to find angle A, angle B, and angle C, right? So, what do I know? Let's call angle A. Let's use blue for angle A. So I know cosine of angle A will be equal to, and let's use purple for B and yellow for C. So I know it's going to be B squared plus C squared, and then minus A squared all over 2 times BC. Okay, so cosine of A will be 4 squared plus 5 squared minus 3 squared all over 2 times 4 times 5. Hopefully I did that correctly. Okay, so what do we have here? So cosine of A will be equal to 4 squared is 16, 5 squared is 25, 3 squared is 9, 2 times 4 is 8, 8 times 5 is 40. So we have that cosine of A is the quotient. Well, 25 minus 9 is 16, so that's 32 over 40, but 8 goes into each of these. 8 goes into 32 how many times? 8 goes into 32 4 times, and into 40 5 times. So I claim that A, so cosine of A is 4/5, which means that A is going to be inverse cosine of 4/5. So that's how I isolate the angle, by taking the inverse function. Okay, so now I have A. Okay, now I need to do the same for B and for C, and I changed the color. Why did I do that? Okay, so let's change this to pink, because I've already assigned purple. Okay, much better. Okay, so now using purple for what I assigned it for, which was B. So I claim that cosine of angle B is going to be the quotient, A squared plus C squared minus B squared. So A squared plus C squared minus B squared all over 2 times A times C. Move that down one. Okay. So what do we have? We have that cosine of angle B is going to be A squared. Well, A was 3, so this is 3 squared. C was 5, so 3 squared plus 5 squared 5 squared, and b was 4, minus 4 squared, all over 2 times 3 times 5. Okay, so what do we have here? We have cosine of angle B is going to be 9 plus 25 minus 16. So 9 plus 25 minus 16 all over 6 times 5 is 30. Let me erase this, make that a bit better. All over 30. Okay, so we have that cosine of B is going to be 9 plus 9 is 18 over 30. So 6 goes into both of these. 6 goes into 18 3 times and into 35 times. So if we have that cosine of angle B, what color should I use for B? Have I already used orange? No. Cosine of angle B is equal to 3/5. So what that means then is that angle B will be inverse cosine of 3/5. Did I mess up the color scheme again? Ah, well, whatever. Okay, I did. Okay, so now we just need to find angle C. Okay, which we did in yellow. So cosine of angle C will be a squared plus b squared minus c squared. So a squared plus b squared minus c squared all over 2 times a times b. Okay, so we have that cosine of angle C will be C was given as 5, so 5 squared. So A was 3, so we have 3 squared. B was 4 plus 4 squared minus 5 squared all over 2 times 3 times 4. So we have cosine of angle C will be (9) plus 16. Oh, why do I have that raised to the 5th? It should be raised to the 2nd. Minus 25 all over 2 times 3 is 6 times 4 is 24. Well, this gives us cosine of C is equal to 0 in the numerator. Okay, so if that's the case, let me write C in red. This means that C is inverse cosine of 0. So at what angle on the unit circle in quadrants 1 and 2 is cosine 0? That's pi over 2. That is 90 degrees. And we know that this is a 30, 60, 90 right triangle because 3, 4, and 5 is a Pythagorean triple. So it had to be a 90-degree triangle, which it was. Okay, so hopefully that makes sense. I'll see you in the next video.